Well, hi, good morning, and thank you so much for joining me in my shop. Today is September 25th. Another gray, rainy day outside. The weather really went from being really quite idyllic to being really crummy here. Not to complain, though. Don't complain, Jim. So, what to do about this radio now? So I've given it some more thought. I wasn't going to have it in here today. I was going to start on another radio, but I'm going to have it in here at least one more day. And what I'm going to do is I'm going to pick two or three easy to change capacitors underneath, because they're easy. And I'm going to change them out, and one by one I'm going to test them on my capacitor tester and see if they aren't like the one I tested in the last video, which showed up to be in really good shape, surprisingly good shape, pretty much like new, really. Very hard to it's hard to believe, in fact, but such was the case. And this is a molded capacitor, ones that are generally known for being unreliable. These are not much better than a wax capacitor, or are they? Maybe these are really extra high quality ones. Now there's black ones, there's ones like this, molded capacitors. The black ones are commonly called black beauties, but there's nothing too beautiful about them. So that's my plan today, is change out a few and test them. And then I can make a decision about doing the rest. In particular, what's concerning me is what I know to be underneath here. It's liable to have 5, 6, 7 of those capacitors under there, maybe more. That's the plan. So the first thing I got to do is tip that radio up. I think I'm going to go build up my strength with some coffee first. Well, there's pretty obviously one right there. Why don't we go after this one? To identify it, I have my book open here, and you can see it right here, but it's not labeled. And here it is again. This time it's labeled C156. C156, and it's in the what is that circuit? That's the so this is the IF strip coming down here. I don't know. Let's see if we can find it. Again, C156. I'm going to try to find that on the schematic here. Probably shouldn't do this live because it's a pretty big schematic here. So 156 in the maybe somewhere around here. So how are these numbered? Sometimes they number these to make it very helpful to find them. Let me see. Hold still. We see 264, 260 something. Just looking at the numbering system. There's no capacitor. Here we are. 103. Capacitor over here, 133. So I'm not sure. Maybe they've numbered circuits a certain way here. 156 is going to be in the ones. I don't know. Did that help at all? 156. Well, I'm just going to have to hunt it down. Here's some ones over here. Yeah. Have you spotted it yet? What's it near? Oh, it's right under this box here. This is the L. Okay, that's a big radio. This has got L34 and 33 in it. Can find L34 and 33, L42, L38, 39. I forgot the numbers already I'm looking for. Yeah, this isn't going well. Okay, I'll find it on my own here. Nothing. It's pretty hard to get certainty sometimes, that's for sure. So let's just go over this. There's the capacitor. There it is there. There's no. This is upside down, by the way, but you can see this small block is this, and this is the can that's missing here. That's no doubt the correct capacitor. And it's labeled there 156. C156. Took me a long time to find it on the schematic, and I'll show you why. It's in the power supply. Huh? In the power supply. The power supply is over here. The capacitor is over here. 156.022. Pretty sure that's what that is. So really here, but one part of this capacitor, like one side, is connected to this terminal, which is a terminal on these coils. The coils are, this doesn't make sense. There's something going on here. Could be more than one numbering scheme for these capacitors. Oh my God, I hope not. I've never encountered anything like this in all the work I've done on these radios over the years. Everything is kind of added up all the time. So the coils that are up, that these terminals are hooked up to, is the where are you? Here they are. It's these coils here. This is the can containing the 8 terminals actually coming down here. 8 terminals. 1, 2, 3, 4. How do you get all the way to 8? So are some of these spare? This is just a handy place to stick this capacitor. This capacitor down here. This is on the one of the heater lines for tubes. 2 V6 and V8 filaments. Well, it doesn't make sense to me that it's over here. And that means not enough caffeine running around in me yet. Okay, so here in the manual I have is a view of the what's in the can that's right above this capacitor. These 8 leads. Whoops. These 8 leads here are these 8 down here. Whoop. Can't show everything at once. So is this helping? Well, first of all, it reveals the fact that there's 2 more capacitors inside the can, just above this third one. There's an interesting note here, down here, for R49, which on this diagram is shown right there. But the note says, not located in T2, but at E13. E13 is a terminal block. E13 in radio receiver R274C, FRR, which I believe is the Air Force number for this radio I have in front of me, from serial number 1570. So my serial number is 2424. Not quite 1,000 beyond this. But it doesn't show the capacitor in question. The capacitor in question would be connected to these leads underneath. And what I'm really trying to see is, are any of these just free terminals that the radio designers are utilizing for this capacitor? Seems pretty strange to me that this capacitor would be located way over here when the power supply is over here. This is E13, by the way, up here. This block of it looks like these have been resoldered. I wouldn't bet on it though. Okay, so what is this revealed? Nothing. So why am I hesitant? Because I just like to know what this part is that I'm changing before I change it. It's tied on this terminal. There's a wire, and the wire goes in the bundle, and goodness knows where it goes from there. The other side is connected to there's a grounding terminal right there. It's all close together. This terminal, the grounding terminal, this terminal, and the capacitor all tied together. So this is a grounded capacitor at one end. Where this wire could go all the way back over to the power supply somewhere. Huh. Oh, there's so many capacitors in here. Looking at them, oh my gosh. One here, 2, 3, 4, 5, 6, 7, 8. Well, I know there's 9 and 10 up above here, and it just keeps going. Because I think it's 30 capacitors altogether. And I would like to change that out based on the idea that it's a 0.02, but I don't know that for sure until I. So here, 156.022, but it's connected to. I can't quite read what that is. That's probably another 0.02, but can't be sure. This just isn't matching at all. Yeah. Okay, let's stop for a bit here. Okay, let's have a look at this. This is a wiring diagram, modern diagram. Clearly, it's been drawn in the modern times, and this has come from. We'll take a look at the top of the document in a moment. So right here is C156. It's exactly in the position it's in. Another ground out to here. Yep, that's exactly what's going on. So there it is, 156, no question about it. And 156 was a, there's a parts list here. Let's just take a look at this document. This is a fantastic document. So I think this is a photocopy or an image from the document I have. I'm looking at this piece of it. So we're going to go way up at the top here. Here we are. So if you want to find C156, C156, same as C. Come on, really? Same as C98. Wow, come on, really? 98. What has happened here? 0.022. Cross it out. Well, it's not the same. Yeah, okay. 0.02. 0.02 is what it is. Okay, I think I can proceed now. Okay, you can see the nice little yellow capacitor sitting there. Let's test the one that I took out, which is really of great interest to me. Now, the number of times I have taken a capacitor out of a radio from the 1950s, like this one, and tested it and found it to be like new is, well, I don't think it's ever happened before, really. You have to be careful with these connections. If the connection doesn't get made properly, then you're going to get a reading as if there's no leak. But there is a way to spot that happening during this test. And that it does take time for the capacitor to charge. So the eye should close and then open with a little bit gradually. The bigger the capacitor, the slower it opens. And if the capacitor is shot and the lead is broken, or if I don't make the clip grab properly, so there's really nothing being tested, if that's really the case, there's no capacitance at all, this thing snaps open so fast it's obvious. Okay, here we go. So 50 volts, what do you say? Open right up. Okay, 150 volts. My gosh, look at it. 250 volts. I don't know the rating on this capacitor. I could know the rating if I took the time to look. I think I can find it on my own computer screen here. Just hang on 1 second, because I think I've got the parts list right on here. Here we go. Okay, same as 98. Right? 98. Well, what am I supposed to be looking for? The rating. There is no rating given on any of these capacitors. There is no voltage rating given anywhere. Well, it's on the schematic. We wouldn't normally put that on the schematic, but I'm looking. No. You know, it's on a low voltage circuit, you know, like an 8 or 10 volt circuit. It's on a heater circuit. So, okay. Well, what can I say? That's 2 capacitors now that I've taken out and tested, and they've both shown to be excellent condition. Should do another one, another easy one. Find it. Is there another easy one? Easier one. Maybe so. These ones up in here are difficult. There's one here. That's not too bad. There's one here. That's not too bad. Also, what about way? Wasn't there one down in here somewhere? I don't remember now. There's one way up in here. They're all over the place. They're out of control. There's one right here. Hey, now that one looks real easy. This one looks really easy. I'm looking for easy here. So these are also capacitors. These are electrolytic capacitors. They're also all over the place. Okay. Let's find out what this one is. It's right at the end of this block. This block probably has a number, like an E number. I can probably identify it and figure out. Was I standing in front of the camera the whole time? Hope not. Okay, the capacitor I'm going to go after is this one right in here. And there's the line coming for it. Did I get it right? Right here. Yeah, C127 is what it is. C127. So what is that doing in the circuit? Good question. Well, I'm going to try to find it on my schematic here. Okay, C127. Uh-oh, where'd it go? Here it is. 127. So it's on, there's a great big electrolytic capacitor here, 10 microfarads on this line, and this line is going up to the grid of the IF driver. IF driver. In any case, it's on a grid circuit, 100K there, 10K there, a filtering system here. This would really this is a huge capacitor. Okay, so this guy, the thing about electrolytic capacitors is they're not great at higher frequencies. So sometimes you'll find, and I'm not saying that's the case here, but you'll find an electrolytic capacitor and a regular capacitor with it in some circuits, especially in power supply filters and that. Okay, so that's the guy. Let's change it. Let's see how big is it. It's a 0.01. Okay, I gotta find a 0.01. I'm very low on these capacitors here. I think I got lots of 0.01s though. Let's see. Yeah, I got lots. 0.01. All kinds of them. There we go. Okay, in you go. Okay, so I have a new capacitor installed here. Here's the one to test. Let's go take a look. See what happens here. Okay, on the 50 volt shot here, eye visible. There it is. Right open again. 150. Right open. Wow. Okay, I think the message is clear now. These capacitors are in great shape. That's 3 for 3. Now one had a short. If it wasn't shorted and we had tested it, I bet you it would have tested just as good as the rest. It got a short in it. Huh. Well, I mean that's both good and bad. That's good. It means I can probably operate this radio without much risk of a failure. But it's also bad because it's going to encourage me to leave all these capacitors in it just the way it is. You know, all the work you do on these things involves risk, and occasionally things get really bad. You can make a bad mistake. I've done this many times. Think a simple thing you're going to do and it turns into a big schmozzle. Why don't we look into the question of what's going on here? So in my other radio, these down here are this kind of capacitor. They're not these open ones. And every diagram I've looked at, it shows them as being the metal type, the metal can type capacitor. If I look in the book here, right down here. So we're looking across the back, and I know it's a lousy photograph, but those are the 4 cans. 4 cans. But I've got a plate with 4 capacitors on it. This is, you know, radio number 2424, so it's an early one of 60,000 they made. So maybe this is an earlier, an early thing. Well, it must be an early thing. Let's look at that other manual that I have on my computer. The fantastic manual. Let's see what it can show here. So, along with these excellent photographs, see, well, there's the ones that are in my other radio, and I've never changed these. I'm trusting that even this one and the 2 under here that are under this big metal plate, great big capacitors under here, they're all original in my other radio. Certainly original in this one. Okay, what are we doing? We're going to look for diagrams that explain the difference here. That's the RF. Nope, not going to find it this way. So again, that's what's in here. And I think that's it. I don't think there's any more diagrams. Just photographs. So this is the kind of radio I have. The other radio I have has this kind of output on it. The one that's here on my bench doesn't have this. Diode output. I don't remember AVC being here. And they've done away with the phono on this one. Okay, is it possible to find anything else that might reveal what's going on in the back of this radio? I don't think so. I think we just have to kind of accept the radio I've got here on my bench is the earlier one with the earlier capacitors, and doesn't have the metal ones. That was a later thought. Obviously, the metal ones are more expensive. What are they doing anyway? Well, what are all those guys doing? I think they're all doing different things, if I remember right. They're all together on the back, but they aren't connected together as such. I can't remember for sure. They're a C58, C160. Yeah, I don't know. Okay, I'm just kind of rumbling around. Look at this. Now this is the look at the kind of capacitors they're showing. They're the same kind that are in my radio here. This is kind of weird. The radio I have here appears to be an older version, 10 years older than the other one I've had for 30 years. The one I had for 30 years had just regular wax capacitors in it, not molded. But this one has molded capacitors. Didn't molded capacitors replace the paper wax capacitors? This seems backwards in my radio. Is there some chance that, you know what, like, because these radios were going back to the factory or going into repair shops where they're working on a lot of these radios, they may have swapped the RF assembly from radio to radio. But my other radio, the whole thing was just paper wax capacitors. There were no molded ones that I remember. So anyway, looking at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 just in this thing. And yeah, amazing, eh? It could be good. I think we should operate the radio again. Let's do that. Okay, have a look at this. I asked Copilot, which I found out is ChatGPT-5. I didn't realize that. I've been using ChatGPT-5 or 4 all this time. So here, I asked this question. I'm working on an SP-600 radio receiver, and I know some of these old radios had killer capacitors in them. These are capacitors that will cause serious damage if they short out. Are there any such capacitors in an SP-600? And here's its answer. You're absolutely right to be cautious. Many vintage radios, including the Hammarlund SP-600, contain components that pose serious risks if they fail, especially paper and electrolytic capacitors in the power supply and audio circuits. Potentially dangerous capacitors in the SP-600. Here are the key types to watch out for. Okay, and it gets kind of general now. Electrolytic filter capacitors in the power supply, and typically large metal can types. If these fail, boom. Okay, I know about those. Paper capacitors, aka waxies. Waxies? I've never called them waxies. Location found throughout the RF, IF, and audio stages. Risk. These are notorious for internal leakage and shorts, which can damage transformers or tubes. Well, again, this is a general answer. I'm asking for a specific. Let's keep going though. Often use circuits are replaced with modern film. Even if they test okay now, they're ticking time bombs. Coupling capacitors to the grid of audio output tube. Okay, this is quite true. Leaky, they can bias the output tube incorrectly. Okay, I know about those. Now we could look at that, but my intention is to pull the output tube, the 6v6, out of the set and not even have it in the set. Especially before I go through and do a bigger job at changing capacitors. Bleeder resistor and capacitor combo. Location across the high voltage B plus lines. If the bleeder fails, the capacitor can retain a lethal charge long after the power is off. Yeah, okay. What you can do? What can I do? Check the schematic. Look for any capacitor directly across the AC line or high voltage paths. Use a variac during initial power up. Test capacitor with the ESR leakage tester. But assume old paper caps are bad. Well, that's what I always do, but we've got test results here that say otherwise. Replace with caution. Use caps with equal or better voltage rating, temperature knowledge. You're aiming for historical authenticity. You might consider restuffing. I've never done that. Restuffing original capacitor cans or using period correct looking replacements, which is kind of what I'm doing. Those yellow ones look kind of okay, but safety should always come first. No, you don't need to put safety first. Come on. Want help identifying specific caps from your schematic with photos? I can walk through them with you. Oh yeah? You can, eh? Okay. Show me a photo of C108. Can you do it? C108 is the first one that I found some images online that show the internals, including capacitor C108. Here they come. But where are they? Oh. What are common issues with C108? Really? Is there such a thing? Here they come. Well, they didn't come. Show me a photo. Well, it didn't work. What's this? What are common issues with C108? There are? Are there any? Look, C108 is a paper coupling capacitor in the audio section. Specifically, it couples the plate of the audio driver tube to the grid of the output tube. Did I pick the wrong capacitor number? That's not what C108 does. This makes it one of the most critically and potentially dangerous capacitors in the entire receiver. Yeah, really? Did I get something wrong here? C108. Okay, let's take a look at the schematic for C. See if I can find it. C. Okay, you go away, and we want to find C. I think it's full of crap. You know what? To look at the schematic, it's better to use the paper one. So let's switch to the other camera here. As much as you might think the paper thing is very clumsy, and it is. Every time you open it, everything is just where it was when you last looked at it. The computer is not like that. So he said C108 is the coupling capacitor. That's C149 right here. Well, there you are. So it's completely right and completely wrong at the same time. Yeah, you do need to worry about that capacitor. And maybe that should be next on the hit parade here. Where's the output tube? The output tube is down under here. There's one under there. For now, I don't think I'm going to worry about it. I think we're going to operate the radio. And once again, be reassured that it's working. I'm getting less and less concerned about operating it as we do more and more tests on it. Okay, let me put these away. Okay, I'm going to drink a little coffee too, so I'll get this set up and then we'll play radio for a bit. Okay, let's give the radio a go. I've got it connected to an antenna. The speakers coming out of the headphones here right into my sound system. Let me put my headphones on here. Hey, where'd they go? Here they are. Using better headphones today. Okay. Now, just one thing. Let's do a little microphone test here while I've got my headphones on. So you see the two microphones up high there. That's what you're listening to. So I'm going to snap my fingers under each one. You're going to hear left and right. So, okay, so this is backwards in my ear. What happened? Did I put my headphones on backwards? I don't think so. That's the right one. So they are backwards. So I'm going to flip them. Now wait, but let me look on my, here, you can look here too. So this is the, if you look very carefully, you can see the VU meter popping up and down on the software. And there's a left and right channel. So I'm going to check and see. Hard to tell. That's left and that's right. So on the recording it's correct. In my own hearing it's backwards. Okay. And if you've got headphones on or you're listening to your speakers and you're separated nicely, you might be able to get yours coordinated with mine here. Okay. So plug it in. I'm going to start it up with the dim bulbs in place. And put the volume up a little bit. What do we hear? Ooh, what's that? What was that? Something that's good. Okay, got something else plugged in here. Oh, right, I was going to connect a wire to the phono output. I never did that, and this is what we were listening to. The humming wire here. Okay, we're on. We're in business. Here we go. So you might have noticed the dim bulbs have come on in the background. I just keep them on for a little bit just to reassure me everything is going okay. Dim bulbs they've dimmed down a bit. All is good. Okay, so we're going to snap on full voltage here. Okay, full voltage today, coming from our nuclear power plant, 109 volts. Got a bit of a hiss and a hum have shown up. Oh, I had the volume right up top here. It should be more like, maybe like this. Okay, what do we got? What do we got? So we're starting on, we're around 16 megahertz. We'll go down. Oh, we can go up. What was there? Something fading in and out. That sharp pop makes me nervous. So we're way up high here. 20. We're way up to where CB is. Look.
To the family, God bless you, and I wish you well. 579 12 gauge with the weekend wave, got down.
There we are. I get a big kick out of listening to, ooh, what was that? You hear that dong sound? What was that? What was that? Microphonic. I think it's microphonic in here. The dung might have been something, heat expanding, and it just popped to a new position and rang this, whatever it is that's ringing.
Hey, bad blood, 579 12 gauge in the keyboard, you know, down.
Okay, back down, shortwave area. Down through like this. There we go. Anybody, somebody. So I'm pretty sure there's a station there. I think that's 770. 15770. But I'm not hearing any modulation. I think that's WWV right there. Where it should be. There it is. I hear it. I didn't have the RF gain up high enough before. Beautiful. Look at it. Right on 15. Look at that. Let's go back up here. It's often somebody around 15,400, but not now. These are all weak stations here.
To help us to save it, okay? Go to suprememastertv.com/Mac. Click the button that
Supreme Master.
One is for
Okay, we're going to drop down a band. I'm going to start at 7.5 and go up. This is CHU Canada. This is Ottawa. Time signal. Come back, come back. Okay, we're going to wait for it to get to the top of the minute. It's kind of funny, eh? You used to use this time signal to set your watch. Now you can use your watch to set the time signal. Not really. So away we go. That's from the atomic clock in Ottawa. Ottawa is about 300 kilometers from here. It's possible to pick up aircraft and stuff like that in here. It's a little trickier with this kind of radio. Using an SDR, it's really quite easy to catch aircraft. This would be aircraft flying over the Atlantic Ocean. They still use high frequency radio to communicate, oddly enough. And it is tough. It's interesting to listen to because they have trouble communicating. So I'm going to turn on the this. I want to hear it. So I have the BFO on now. Get a better idea of what these signals are. Yeah, it could just be a noise signal, or it could be some kind of communications. Probably just noise. Okay, we're coming into a shortwave broadcast band. I'm going to flip off the modulation switch here. We're just on straight AM. Should get a station right up in here. Come on.
No temptation as usual except will come into man, but God is faithful.
This is 9330. It's very, very close. You got a bit of a parallax going on. So that signal, that signal is from the United States. There it is. So the bandwidth is quite wide. I usually have mine on the 3. Let's see if we can get it to work on the 3 here. No, I'm gonna have to clean that. I should have done. There we go. I should have done that this morning. It may go off on its own. That's Brother Stare speaking. WWV. Not gonna happen here. No. And radio stuff in here? No. Too early in the day. Shortwave band coming here. I got a really strong signal. I start checking out this meter a little bit. I think a strong signal. This will do it. Okay, how come that meter's not doing it? Whoa. Hey, who put this thing on a moving? Yeah, who did that? Radio Marti. Did that meter just jump? 600 millivolt full scale reading now. Looks like a pretty good zero here. Oh, that's a meter go up. What's going on there? What's happening? How did that happen? The connection's loose. Okay, let's just turn this down a little bit there. Hey, connection loose? Are you serious? Can it be that simple? So I was just putting the test leads on the two big screws back there, and in the middle of doing that, the thing came to life. So it's either a loose wire or these connections are where are the connections? Where are they made? I gotta wiggle them around. Okay, we gotta listen to the station while I'm doing this too. My beloved stick here. Era un cubano desarraigado de lágrimas negras sobre las teclas blancas de su piano. En los años 50, Bebo era figura cotidiana en el mejor cabaret de Cuba, Tropicana. Alternó con lo más exquisito de la época ganando... Okay, I'm going to loosen and tighten the screws, the nuts a little bit. Comenzó el triangular siempre apegado a lo mejor que sabía hacer. Pero las cosas lindas pasan a cualquier edad. Y a los 70 y tantos años, Bebo cabalgó de nuevo. Grabó discos con amigos viejos y nuevos. Hizo documentales, ganó premios. Volvió a encarnarse a escenarios para que la gente diera palmas por él. Something pretty weird here. Is there a light behind here? I don't think there's a light behind here. Is there? Because one of the wires here. One of the wires is coming from the light bulb system right into the back of this. I'm having a hard time seeing it. Put this light over here, Jim. Come on. You got this Okay, I'm not sure what you're seeing. I don't see there's a light in here. But I see that the 6 volt thing's coming over and it's tying to a terminal there and then heading out. Well, I don't see any light bulb though. I mean, there's another wire. What's going on here? I don't know what's going on. Let's look at the schematic. We need to look at the schematic for the lights. How did I get this to work? What was I doing? I was taking voltage readings and suddenly it started working. Let's do that again. I wonder if I was shorting the supply from the lights onto the meter. I could have been doing that. Well, I don't know why. I'm sure I saw that meter work. Nope. So, oh. What happened there? Wow. Okay, so what happened there? I did short it briefly. And now it's working. Can't believe it. Just let me just check my pants for horseshoes there. Oh boy. I know what it was. Bert showed up and fixed it. Okay, don't know what was going on here, but look, it's working now. Perfect. It's showing. So this is when it's done properly, this is a calibrated meter. A calibrated meter. And it says right on it, decibels from 1 microvolt. So 0 represents 1 microvolt on the antenna, if it's calibrated, which I will eventually calibrate someday, somehow. But wonderful. Okay, you know what? I think we're gonna maybe just quit right here because no, we gotta go down and listen to the broadcast band a little bit. What are you doing? Don't jump up there. No, don't jump up there. I've ruined a lot of his. I've messed up the shot for the cat here, buddy. I think you might have to go down. Oh yeah, you gotta go. You gotta go, man. Say hello to the nice people. Hello. We're going down and out. Shut my door tight. Okay, back to what we're doing here. I wasn't going to go up there, I guess. Just keep tuning along with the phone. Now the meter works, it's kind of neat. Just gonna... Ooh, what happened there?
Necesario para crear las baterías de fibra podría caber en una pequeña habitación. Café digital. Sigue el ritmo de la ciencia y las nuevas tecnologías.
En Café Digital, por Radio Martí.
Did it just snap up higher? You got a copyright hit from that?
Has everlasting life, and shall not come into judgment, but has passed from death into life. Most assuredly I say to you, for the hour is...
One of the first uses of radio here in North America was broadcasting religious broadcasts in, I think, New York City or somewhere like that. So here we are so many years later, and...
the Son to have life in himself, and has given him authority to execute judgment also, because he is the Son of Man. Do not mock.
Son of Man? Son of Man? What? Should get some, there we go. This is FT8. Turn the modulation on, or the BFO, it sounds more like what it should sound like. A cacophony of stuff. There's not much else to get here. Any hand guys talking? It'll be interesting. Don't hear any. It's too early in the day for this band, but the FT8 guys are going 24 hours a day. Okay, noise doing 7 megahertz. We'll go right down to the towards the broadcast band here. It's going to get probably a lot noisier right here. Not so bad. So with 3 megahertz, this is all crap and crud. Crap and crud. Wait till we get down to about here. So you gotta kind of, what are these? What is this that I'm picking up? Whatever it is, it's a little shaky. I don't know, but it's just repeated all the way up. Like, it's silencing the radio. It's so strong. I have no idea what it is. Is it definitely the antenna? Let me just turn the antenna off here. Did it go away? I think, yeah, the whole radio went silent. Come back. What happened? Okay, it's a little bit funny, but so there it is anyway. Okay. What I did there didn't make a lot of sense. We're only at 1.7, so we're just coming into the extended broadcast band. You might find the community radio here, and this thing that keeps showing up. Okay. Getting close to 1600 now. It's still there. Not doing so well. That's probably a very low power community radio from somewhere here in Ontario. Probably Toronto. Dirt right at the end of the run. Okay, we'll go down. Now we're going to go right to the bottom of the broadcast band and work our way up. There's a station rating here. Let's go up to make sure things are working. The meter's hardly lifting here. We're down here on 3. Might be better on 8. This is behaving exactly like my other radio. It's exactly, I feel like I'm using my other radio. I thought we were doing better on this band. Oh, there we are.
AAA, I think. They sent him down to try to get right because it felt like his mechanics were off. They had to call up these 3 working stations. At this point,
let's go back down and try this Buffalo station.
Orange made a couple of starts in AAA he really rushed through the minor leagues. He was only 22, and he was so promising at first.
Sorry about
but then
my
it
camera.
Kind of feels like it's a little too much for him at this
Hey,
point.
look.
We should be
But I'm going to get control over this camera. So I look into it. I got to download the camera's software. If I download the camera's software, then I can gain control over these features that are automatically operating, the automatic zoom and all that stuff. Great. So I go to download it, and what do I get? I get a message saying, when I go to the web page where the download occurs, I get a message saying, "Don't go there. It's dangerous." So I bypass that first message. It says, you know, the certificate isn't matching or something like that. I bypass that, and I get another message now coming from my operator, Rogers Cable, the cable operator. Big red thing. "Don't go there. It's dangerous." So I hadn't downloaded, so I didn't go there. So I didn't download the software, and I don't have control over this camera. That's the story there.
October 1. But it'll be really interesting to see what they do.
Thank you so much. Stay healthy, David. All right, up.
So it's picking up stations, but it's missing some, like 610 here from St. Catharines, similar to Buffalo. It's not doing it.
What about your own kids?
And this 680 should be higher than here, I'm pretty sure.
Maybe extra busy with them.
740. 740. Swamped out by this interference. You can hear them behind there. Stomped on. Oh, it's terrible to listen to, isn't it? So I'm trying for 860 now, a fairly strong station, but did my intent go off again? No. So the reception's not impressive. I think that radio can do better. I think the antenna's got the signals. And then we get this thing happening again here. So let's try 1010. It's being stomped on. 930. Buffalo. No hope there. Well, something's going on, but that's why I like having multiple radios, because there's something like this, you know, you start wondering, is it the radio or is it something external? Let's try the antenna again and see if this just totally disappears. So it's definitely on the antenna. And I'm not surprised. Don't know what it is though. Okay. Had lots of fun. Operated the radio for quite a while this morning. Nothing more bad has happened. So I think what I can probably do is put this guy into my listening location, start using it. I have the other identical radio. I can compare it. It'll be lots of fun, and get more in tune with. That's a good phrase. Get more in tune with how well this thing tunes up. Then probably the next step with this radio won't be capacitors. It'll probably be an alignment effort, and there's a major effort in this radio to do the alignment. The IF alignment's easy, like most radios. So I shouldn't say easy, straightforward. The RF alignment is difficult, challenging, mechanically challenging. Okay, fantastic. I'll shut her down. Fantastic, really fantastic. I can't, you can't appreciate how excited I am to have this radio. Okay, well, you have a great day, because I'm going to have a great day, and tomorrow there will be a different radio sitting here for me to mess around with. See ya.